Okay, similar figures. We're going to talk about these. We're going to talk about congruent shapes as well, and you're within difference and you're between difference, everything like that. Now, before we start, I just want to do this. It's just a little task which will help you out. I want to know timesing by 2 is the same as dividing by what? And then continue that to times by 3 is the same as dividing by what? Now, if you don't know how to do this, let's just start with a number. Let's start with 10. I'm going to do 10 times by 2 is 20. Okay? But then also I want to do is, what about 10 divided by what is 20? Okay? And try and think about what it is, and just guess on your calculator. I'm not going to give it to you. See if you can work this out. So pause the video. Right, in this case, it actually is, it's divided by a half. So it's going to be divided by a half, it's divided by a third, divided by a quarter. It's just stuff you really need to know. Times by 5 is a fifth. So times by 2 is a half, so divided by 2, and this is divided by 4/3. What's the general rule? Well, it's like a big clue here because there's a big word here called reciprocals. And essentially what you're doing is you're just flipping it over. Yeah? And it just helps you out with your scale factor. So if I know something's a scale factor of 5, I know going like from the smaller shape to the bigger shape, I know if I'm going from the bigger shape to the smaller shape, I'll be timesing it by a fifth. It'll just help you out a bit later. Okay. Now I need a little bit more stuff. Enlarging. Yeah, just so you know about enlarging and making things bigger, making things smaller. Remember, the angles will always stay the same. So let's say I was doing this one here. I was doing by a scale factor of 3. What I'd do is I'd count my width, which is 4, and my new shape is going to be a triangle. Obviously, you're going to draw this neater, yeah, and to scale as well. It's actually going to be 36 squares, and my halfway point is still going to be my halfway, and my height. Here, my height is 3. So I'm going to have to do 3 times 3, which is 9. So my height's going to be 9. Okay, and obviously the harder colours makes it more difficult. 3/4 is always interesting because something nice happens to do with the shapes. I'm not going to show all the answers, but pause the video. Right, if these shapes look wrong, they are wrong. Just to be clear, this one here you halve all the sides, so it should look smaller. We still class it as an enlargement. That's slightly smaller, and the other one's smaller again. We need to talk about similar figures, and we need to talk about congruent figures. Right, congruent figures have the same size. Yeah? The only thing they might have that's different is they might be rotated or they might be reflected. So when you're doing transformations, translations, rotations, and reflections are all congruent because they are. Yeah. Similar, on the other hand, they're enlargements. Yeah. But they can also be a reflection and rotation, but also enlarged. Okay. So just keep that in mind, and you've got to think of which sides do correspond to each other. So if I had a triangle like this and I had a similar shape which was big like that, yeah, what you must know is my bottom bit still corresponds to my bottom bit, but my right hand side of my smaller shape corresponds to the left hand side of my bigger shape, and both the hypotenuse correspond. But have a look at these shapes here. I want you to pair them up. Think about which shapes are congruent to each other, which ones are similar to each other. Pause video. I did some very sophisticated colouring with this. These are all the ones that I found that are congruent to each other. And these are all the ones that are similar to each other. I couldn't find H seemed to be on its own. The only other thing you need to be wary of is that the semicircles are actually different sizes. And remember, similar shapes are also congruent to each other. Yep. Right, determine the scale factor. This should be really nice, something you should be able to do. Now, all I need to know is this: I've got shape A here, I've got shape B there. What do I have to multiply A to get to B? Okay? And because we've got all the measurements, there's loads of things we could do. But essentially here, what I'm going to do is I'm going to get this corresponding side, corresponds to that one there, and I'll do the one that I'm going to over the one that I've just come from. So it's going to be 20 over 5, which means my scale factor is 4. Okay? And that makes sense. Okay? So this one here is going to be 4. It's getting bigger, so it should be above 1. So going backwards, I know this is actually going to be a quarter. Now, I didn't have to use 20 over 5. I could have used any of these. I could have used 24 over 6. It's exactly the same. Or I could have done 8 over 2. Now, they all come to a scale factor of 4. Okay? Yeah. This one here. These are diagonals, but maybe I don't need to count them. Maybe I can just count height. So I know my height here is 2. I know my height here is 7. So my scale factor is going to be 7 over 2. Okay, which is 3.5. And it's above 1, so it makes sense. On there. You can see it really, but let's say I'm going this way round. I'm going to have to do the one I'm going to from the one I've just come to. So it's going to be a half. And you didn't have to use 10 over 20, you could have done 6 or 12 or anything like this. Which is good, but we only really need this if we're using finding missing sides. Let's do scale factor. And I've only got one side here that corresponds to each other, which is my 6 and my 9. So going this way, I'm going to do 9 over 6. Which I'm going to type into my calculator. Which I've got as 3 halves. Okay, or 1.5. This is above 1, so it makes sense. So going backwards, I know it's going to be 2/3. You could divide by 1.5, but I just think it's a bit nicer to divide by 2 times by 2/3. So let's do the top one. I'm going to have to do 6 times by 2/3 because it's going the smaller distance. Which means my height here is, my length here is 4. My diagonal there, I'm going to do 2/3 again because it's getting smaller. Which means this one here is 5. Let's do the one on the right. I'm going to have to do 3. I'm going to have to times by 3 halves because it's getting bigger. Which means this is now 4.5. This one here, do a bit of time to sort out. I'm going that one there. My TV and my F to H correspond, so it's going to be 3 over 15. But if I want to do it, 0.2. That's below 1, and it's getting smaller, so again it makes sense. So now I'm going to have to do this one here. I'm going to have to do 10 times by 0.2, okay, which is 2. And yeah, good. Again, these are similar, but you've got to think this is sort of like rotated as well. So like KD corresponds with RZ. And sometimes it's sort of like nice to colour in your corresponding sides, so it doesn't confuse you, but of course you don't have to. And I'm not going to colour them all in, I'm just going to colour a couple in, so you get the idea. So now I need to do a scale factor from the smaller one to the bigger one. I've got quite a few pair of sides I could choose, but I'm going to choose the 2 red ones. So I'm going to do 63 divided by 9, which is nice because that equals 7. So now I've got a scale factor of 7 from the smallest to the biggest. The question mark's there, so I'm going to have to do 13 times 7, get the size on the bottom, which equals 91. So my answer is 91 metres. Right, there you go. All colours are corresponded for you. Do one more for you. Again, it's slightly rotated. I'm going to do this top one. So I know that 8 actually corresponds to 6. I want to go from the big to the smaller one. I'm going to have to do 6 over 8, which will cancel down, which makes 0.75. NQ will correspond with JG. Yep. So I'm going to have to do 28 times by 0.75, which means my length here is 21 metres. Okay. That's his questions. The only thing I wanted to point out is number 4. This is not actually a true right angle triangle, so don't try and do anything smart here. Just stick with similar shapes. But this one here is a right angle triangle. Right, pause the video, see if you can work out all the missing sides, not just ones with question marks. Okay, here's all the answers that I got. And the reason why I had to say is this one here, this one here is a true right angle triangle. And I'll be honest, if you've got an exam paper, this would give you a true right angle triangle. You could use Pythagoras, you don't have to use similar shapes. But on number 4, Pythagoras doesn't work. There's a bit of a misleading questions, but that's just where I got the answers from, really. Right, there is a bit more to this, and you need to go back to like your equal angles. So if you see any one of these shapes, these are corresponding alternate or vertically opposite angles, then you know this might indicate that they're similar shapes. And you know they're similar shapes because the angles are the same. Right, so we've got this one here. Now we've got a smaller triangle, and we've got a bigger one. Now what you need to do is you might need to prove that they are these similar shapes. Now similar shapes means the angles are the same. So I've got this right angle here and this right angle there. They're both right angles. Okay. My top angle is shared by both shapes, so that's definitely going to be the same. And this one here and that one there, yeah, these are actually corresponding angles. And you might actually have to say in your exam that these are corresponding. Now let's put some measurements here. I've got 4.8, and this one here is 10. My bigger one, my base is 12, and my height is 10 plus x. Please don't think that's 10x because that's something totally different. Now we have to do the scale factor. It's nice because I've got an actual number there and a number there. So to get from the smaller one to the bigger one, I'm going to have to do 12 divided by 4.8. Let's type into the calculator, see if that brings a nice number. So 2.5. So now I've got times the smaller one by 2.5 to get to the bigger one. So I'm going to have to, I know 10, which is my BE. And if I times that by my scale factor, that has to be the length of the bigger one, which is 10 plus x. Now if we solve this, I've got 25 equals 10 plus x, minus 10 for both sides, so I've got 15 equals x. So I know x is 15. Now the question might ask you what BC is, okay? And BC is going to be 25. So like here. But see what the question says. Okay, so the first thing you've got to ask yourself is, are these two triangles similar? And we just got to prove that all the angles are the same. So first of all, I'd say ACB, which is this one here, is vertically opposite to DCE. And remember that vertically from vertically opposite means from comes from vertices, not because one's on top of the other. Now ABC is an alternate angle to CDE, which means two of them are the same. And I'll be honest, if two of them are the same, the third one has to be the same because it has to equal to 180. But I'd say BAC is alternate to CED. Okay. Now I've got this. You've got to realise if you're looking at it, you have to know you have to rotate it. Now again, I do like to draw my triangles because I find them just like so much easier. So I've got my smaller triangle and I've got my bigger triangle. Now my smaller triangle, what I'll do, I've got my base is 12 and this is the only side I need. For my bigger triangle, my base is 20 and this side here is 15. Now I need to find my scale factor. Let's do it from the bigger one to the smaller one. So I'm going to have to do 12 divided by 20, okay, which gives me 0.6. So I'm going from the bigger one to the smaller one. I'm going to have to times by 0.6. Because 15 and x correspond, I know to work out x is, I'm going to have to do 15 times 0.6 equals x. 15 times 0.6 is 9. So I know x is going to be 9. It's more than 15, so it makes sense. Here's some questions for you to do. Copy them out, please. And I would, if you need help, I'd draw both triangles and I'd make them like so they match up to each other. Go, pause the video. Guys, here's your answers. Hope you enjoyed the lesson.